Hello there, welcome again to this tutorial on differential calculus. In this video we'll be looking at quotient rule. So we go. Given the functions v equal to f of x, u equal to g of x, and y equal to u over v, then the y dx is equal to v du dx minus u dv dx all over v squared. This is called quotient rule for differentiation. Solved examples. We have problem 1. Find the derivative of each of the following functions. A, f of x is equal to 3x squared minus 2 all squared over x cubed. B, y is equal to x raised to the power 6 over square root of x squared plus 1. The rule here is quotient rule. This is this over this, u over v, u over v. So we bring in the quotient rule so that we will now start the solution of the problem from A. So from here we can label this as u over v, where the numerator is u and the denominator is v. So from here we find the u dx. To find the u dx here, using the chain rule, we have 3x squared minus 2. Find the derivative of what we have inside the bracket first. That's going to give us 6x here, and this is 0. Then multiply by the power here, it gives 12x. So we have 12x, bring the brackets. Then reduce the power by 1. 2 minus 1 gives 1. This is still the same thing. Therefore, the u dx is 12x into 3x squared minus 2. Then we go ahead to find the v dx. Here, the v dx is 3x squared. If you multiply by the power, that will give you 3x cubed. Reduce the power by 1, which gives 3x squared. Now we go ahead to find the y dx. We substitute into this formula. We have v here, and our v is x cubed, so we have x cubed. Du dx, our du dx is 12x into 3x squared minus 2, and then we have minus u. Our u is 3x squared minus 2 all squared, and the v dx is 3x squared. We have a 3x squared all over v squared. V squared, that is x cubed squared. So we go ahead to simplify the numerator and denominator. X cubed times 12x will give us 12x to the power of 4. Then we have the bracket minus 3x squared into 3x squared minus 2 all squared, then over x raised to the power 6. This is 3 times 2, which gives x raised to the power 6. Now we can factor out the numerator. I look at 12x4 and 3x squared. 3x squared is a factor of 12x4. So we have that factor there, 3x squared. And we look at the brackets. This is 3x squared minus 2 to the power of 1. 3x squared minus 2 to the power of 2. So this 3x squared minus 2 is a factor. So we bring out 3x squared minus 2. Now we factorize 12x4 divided by 3x squared will give me 4x squared. This 3x squared minus 2 divided by 3x squared minus 2 will give us a 1. So we are done with that first part. The second part, 3x squared here divided by this 3x squared is 1. So we don't have business there. Then 3x squared minus 2 all squared divided by 3x squared minus 2. So it will go with 1. So we'll be left with 3x squared minus 2. Bringing it here, this is multiplied by this will give us minus 3x squared. This minus multiplying minus will give us plus 2 all over x to the power of 6. This goes with this, we'll be left with x raised to the power 4 at the denominator. We'll only be left with 3 here and 3x squared minus 2. Simplifying this, 4x squared minus 3x squared is x squared, then plus 2 over x raised to the power 4. This is the derivative of the function in A. So that is f prime of x, or dy dx. So we go to problem B. For problem B, we let u be equal to x raised to the power 6, and the u, the x there will be 6x to the power of 5 multiplied by this 6, reduce the power by 1, so I have 6x to the power of 5, and our v is x squared plus 1 to the power of half. I've written that in index form. So differentiating this, we have dv dx. Differentiate what we have inside the bracket. That's 2x multiplied by the power half. It will give us x. Bring the power. Reduce this power by 1. That's half minus 1 gives negative half. So we have it to the power of negative half. Then we now go ahead to find the y dx using this rule. Our v is square root of x squared plus 1, and the u dx is 6x to the power of 5 minus u. Our u is x to the power of 6 multiplied by the v dx, but this is this, we have it as this, then over v over square root of x squared plus 1 squared. Squared it, this is v squared. Now we go ahead to simplify this. 6x to the power of 5 root x squared plus 1 minus x raised to the power 7 into x squared plus 1 all to the power of negative half. Then divide by the square root. Here we remove this square, so I'll be left with x squared plus 1. We can go ahead to still simplify. X5 is a factor of this, so I have x to the power of 5, and here x squared plus 1 roots. Yeah, this is a factor. This is a factor. It's a factor. We can now factorize here. Factorizing 6x to the power of 5 divided by x to the power of 5 will give us 6, and this is x squared plus 1 to the power of half. Dividing it by this will give us x squared plus 1. Yeah, it's just like having m to the power of half divided by m to the power of negative half. Since it is division, the half here will be plus half there. We'll be left with m to the power of 1, which will just give us x squared plus 1. Then minus x to the power of 7 divided by x to the power of 5 will give us x squared, and since this divided by this will give us 1, that's the numerator, over x squared plus 1. We go ahead to simplify this. We still maintain these first two factors. 6x squared plus 6 here. This is x squared will go with this negative x squared. We'll be left with 5x squared plus 6 then over the denominator there. Now I want to rearrange and see if this can divide this. This is x to the power of 5 into 5x squared plus 6. If I take this to be m, this x squared plus 1 to be m, this will be m, so I'll be left with m to the power of half divided by m to the power of 1. This is m to the power of negative half. Negative half minus 1 will give us negative 3 over 2. So I will have my answer as m to the power of negative 3 over 2. And I can write this as fraction. Writing it as fraction, I have 1 over square root of m cube. Square root, this denominator will form the square root. This power will still remain as, so that's our denominator here will be, since we are saying m is x squared plus 1, so we have square root of x squared plus 1 cube, and that is the derivative of the function in problem 1b. So we've done justice to this problem on quotient rule, and we are stopping this tutorial here. Remember to check the description section of this video on our YouTube channel to get links to other videos on differential calculus. Until I come your way again, goodbye.